Hello and welcome back to Let's Program with CNTier. Continuing on with the timeline tool. Last time I started working on a new algorithm for doing the positional thing for the timeline overview. And I kind of got to a point where I'm like, okay, I need to figure out exactly how I'm going to approach doing this. So in between episodes, I have done that. It's on a lovely piece of paper. And I have right here a note that I should only do this processing right up here if I'm not on a single branch. Now, technically, this will probably go through, and I'm pretty sure if I don't have anything, I'm not going to have any child nodes. But I can just skip doing all of this code right here if I say don't do this if it's not a single branch. So I figured I might as well go ahead and do that while I was thinking about it. So I then kind of did some processing. So I have a couple of cases that I identified. So the first one is if we don't have any other children, then it becomes really easy. Any other nodes below us that are timelines, right? We just find the one that's the widest, but we also need to take into account cumulative width. That's what I'm going to say. Cumulative width. So what cumulative width is going to be, I didn't think of this before I started going through this thought. So cumulative width is going to be an interesting problem. Okay. So what I'm going to want here is if there is a child before us, so there's definitely one thing that was very, very clear. If there's a child before us, then we need to look among its children, and find the candidate. Done. Okay. So, well, return. Yeah, it's return out of this. Because what we've got right here is a classic case of we found what we needed. So we're going, if this has a child, we're going to find the rightmost among this child. Because one of the things that I determined when I went through this is that it will always be the first thing that we run across that we need to search down. If there's a child, it'll be the first one. So what I'm going to go ahead and do is I'm going to add a new function, timeline event node, search for rightmost, timeline event node, start. Okay, so what I'm going to go ahead and do, and I'm going to figure out what that needs to look like later, but this right here is going to be timeline parent dot rightmost node equals search for rightmost searcher dot child. Okay, because this is a case where we find the rightmost child in the first one that we identify of these, and then we're done. So that finds what we're looking for. If we don't find that, then what we need to do is the first thing that we need to do. This is very, very important. We need to skip everything at the same time as this. So, if searcher dot when dot raw value is equal to timeline parent dot when dot raw value. Okay, so we want these to not be equal. Okay, and the reason for that is because, well, first of all, if these are equal, actually, searcher needs to be timeline parent dot previous. That way we're not looking at ourselves, and this should be timeline parent dot next. I mean, right here it's not technically important because this is going to skip over it anyway, but we need to skip over everything that's to our right because we're not being affected by that, because that stuff is logically after us. We need the things below us, the things below and before, not the stuff that comes afterwards, if that makes sense. So that's kind of a complicated little thing there. But we only want stuff below us, not stuff at the same time after us. Okay, so what we want to find here is okay, so candidate is going to need to be if candidate is equal to null, and okay, so the first thing that I need to do is if searcher dot child does not equal null, then so if we have a child, then find the rightmost of that child. Okay, so this is going to be timeline parent dot rightmost node equals search for rightmost searcher dot child. Okay, so that's predictable, and then return. Find the rightmost node among the children, then return. Okay, so remember the reason why this works is as long as I have my algorithm, my planning correct, is that what's going to happen here is we're going to go down, and the first one that we run into after we've gone to our right and skipped everything on the same line as us, which is what this not equals sign does. This skips everything on our same line. So we want to skip everything on our same line. And once we've done that, if there is a child node, then we want to base our position off of that guy. Okay? So if there isn't a, if we don't find a child node, then we need to do candidate processing, right? Because we care about the candidate at this point. So if we get to the very end, if we don't find a candidate, then we don't need to assign anything. It's at the end of the timeline, so it doesn't matter. But if there is a candidate, then what we need to do, or if there is stuff below us, we need to find a candidate now. So else, so there isn't a child, which will be most cases most likely, then do candidate processing. Okay, so here's the thing that kind of gets interesting. So this doesn't have a child. That means what we want here is so if candidate is equal to null, candidate equals searcher. Okay, because searcher is the node we're looking for. So if we don't have a candidate, just grab the first node we find. Otherwise, check the positioning stuff. Okay. So here's the thing that becomes interesting, is I need to keep in mind lines, which makes this significantly more complicated than my initial thought process was. But the fundamental idea here is if searcher.width size.width is greater than candidate.size.width, candidate equals searcher. Right? That's the basic algorithm. Doesn't account for lines. Okay, so I obviously need to fix the line problem. And I'm going to the difficulty with that is I need to kind of identify the cumulative positional information, but I don't have any sort of Well, if there's a child among these, though, I'm going to go into that child and hunt from there. But I need to find... Okay, so I need to do some line processing. Okay, so... Huh. Oh, lines just make this way more complicated. Because I had the algorithm with this sort of thing going on, and now that I'm like approaching it and remembering like lines, that suddenly becomes really where a lot of the complication lies. Because what happens with the lines is they screw everything up, basically. Is the short way of putting it. Because the line could the tail end of the line could be wider than if there's nodes in between. So I'm needing to like I need to account for the lines. I'm going to just use this raw not accounting for lines algorithm first. It probably won't look quite like how it will need to account for lines, but my initial thought is that I want to get the shape of what this kind of wants to look like, and then kind of test that a little bit, and then I can identify, okay, how do I account for lines? And that's going to probably need to just be another off-screen, I think, about this session. I wish I had thought about it beforehand and before I hit start record, but here we are. Okay, so search for rightmost. We're given, with this, a timeline to search down. One thing that I should do, actually, while I'm thinking about it, is if we make it this far without assigning, use the candidate. Okay. And in this case, what we're going to do is candidate, if candidate does not equal... No, I can just go timeline parent dot rightmost node equal candidate. If candidate is null, then this is just going to reassign null to it, so it doesn't matter. Okay. So what we need right here is this is the node that we're starting at. So this is the first node of the new timeline. So timeline event node candidate equals start. Okay, so we're always going to at least use that node. Okay. Now, what we want to do is we're just going to use the same sort of algorithm as kind of what we're doing up here. And we're going to say if start... start does not equal null. Okay, so if start.child does not equal null, start equals start.child. Okay, so we're just going to go into the child if there is a child, because this is how it works. Now, technically, this is going to run into problems with timeline lines. So iterate. Let's see. So our first candidate is the start node, starting node. Iterate over candidates. So again, like I said, this is going to run into a problem where if we have a line, right, I need to go to the end of the line to look before I can go into the child node, if that makes sense. Because this is going to not go quite far enough. But I'm going to kind of get an initial shape, and then I'm going to start accounting for lines as I go along. And probably after this episode, where hopefully I'll have something that we can like begin looking at. After this episode, I then can take some time to kind of figure out an algorithm for accounting for these lines. So, water break. Remember, it's important to keep hydrated. Okay. If there is a child node, we want to find our rightmost among that. Note doesn't account for lines. Okay. So this is important. Else. Okay. So otherwise, let's see. Start equals start child. Candidate equals start. So I want to do this. Update candidate to our new timelines starting node. So this is important because otherwise, like this is when we need to update the candidate. So otherwise, if candidate or no, if start.width or size.width, excuse me, is greater than candidate.width size.width. Keep flipping that up. Candidate equals start dot equals start. Start equals start dot next. Okay. So what we're going to do here, if there isn't a child, check to see if this node is wider than the previous candidate. If it is our new candidate. Advance to the next node. So what this algorithm should do is, say we're at a timeline. It should go, okay, we're looking, we've gone down and say we've identified, okay, we have a timeline. It will go into that timeline and it will check, okay, if there's a timeline in here, then the top one is the one that's going to push us the most, right? Because anything below that is going to get caught later up in the algorithms and moved over. So that's going to shove this over. So we want the first one that we find, but there's a little bit more complication because we actually need to account for lines. But we want the first one that we find, and that kind of resets our candidate to be at that start. Then we go basically down that until we don't go down a new timeline, and then we go through the rest of that. We go through that new timeline where we're not finding a new timeline, right? Basically, the timeline that does not have a split timeline in it, we go through that one and find the widest node, and that becomes our rightmost node that we're assigning back into stuff here and here. So there's a couple of problems with this that I know right away. The first one is that this doesn't account for lines, so it doesn't actually find the, quote, rightmost, unquote, timeline. So if there's another timeline to the right of this one will get caught in that first, which is clearly incorrect and should be fixed at some point in time. But the issue with that is I need to do additional tracking. So what I'm going to go ahead and do is I'm going to make, let's see, child haver tracker equals null. Okay. So what this is going to do is a slightly more complicated algorithm right here. So if start does not have child, or if start has a child, if start.next does not equal null, actually, okay, I might not need this. I just need to think through this. Unfortunately, because I didn't pre-plan this, it's going to, okay, take a little bit more verbal thought. So while start.next does not equal null and start.next .when is okay. So I'm going to actually do this equals start. Actually, no, I don't need that there. I'm going to go ahead and actually update this here. And the reason for this should become fairly clear. Actually, I do need child haver tracker equals start. Okay, so I need a child haver tracker dot next is equal null, and child haver tracker. I'm just gonna go ahead and move this back down here. Dot when is equal to start dot when dot raw value. This needs dot raw value. I know that looks silly. It'll get cleaned up in a bit. Okay, so while that is true, what I want to do is okay, so we'll start dot next not equal null, and it's next. Okay, so search for nodes with children on the same line as this one. Okay, so I want to while there is another node on this line, if child haver tracker. Okay, so child haver tracker should equal child haver tracker dot next first. And the reason going to this first, no, actually, I don't need to do that because I can just have this equal start dot next. So if it is not null and it's at the same timeline spot as start, if child haver tracker dot child does not equal null, start equal child haver tracker. Child haver tracker equals child haver tracker dot next. Okay, so remember, let me do this to format that better. Okay, so here's what my thought process is with this. So while there's another node on this line, so remember this is set to the next one. So if it is not null and its when is the same as starts when. So starts next and this one, you can't see my hands, but I'm holding them up in front of me to demonstrate. So we have actually, here I can make a comment. So this is start and this is on the same line, child haver tracker. So while this state is true, if this guy has a child, we're going to node, etc. We're going to check through all of these and say, okay, so here's our start, here's child haver tracker. We're going to update start to a child if there's a child on this same line. As soon as this is not on the same line, it'll be like, oh, okay, we're done. That's going to update start, and then start can equal the child. So what we're, just to comment this a little bit more, if there is a child in a further along node on the same line, go to that node with a child rather than using the earlier node. Okay, so that's what that's going to do. Keep checking for children. Now remember, this is going to be on the same line. So as soon as this is on, as soon as we're come down here, it breaks, right? So as soon as child haver tracker comes down here, it breaks. But if this one or any of the ones in between have a child, it will jump it to that one, right? And then it'll go to the next node and keep checking. So this this should properly account for lines. Okay. So now that accounts for lines when it's looking for the node to the node to search for children below it. Now, what this cannot account for, so this right here, note does not account for if the line extends long enough that the rightmost child doesn't that the rightmost child does not account for if the line is long enough that the rightmost child should be the last node on the line. Okay, and the reason for that is because it's just very, very difficult to know when that's the case right now. I need to figure out how I'm going to calculate that. But I think we've gotten this to a point where I can go ahead and see if it compiles. Okay, it compiles, so that's good. You can see that in the lower left corner there with build succeeded. So let's go ahead and run a couple of tests, I guess, just to kind of make sure this is working at least a little bit. Just waiting for it to load all of the stuff. This happens. It's okay. We just deal with it. And then what I'm going to do soon is, let's see, add a standard event, split timeline, split timeline, split timeline. Okay, so what I want to do is I want to put this, let's go ahead and put this event at 500. Let's go ahead and put this event right here at 75. Let's put this one also at 75. And let's go ahead and leave, let's go ahead and leave it like this. So I'm going to call this bottom event, first 75, second 75. You can see that they're kind of like created in a different order, but that doesn't matter. I'm not going to worry about like trying to sort these. That would be a nightmare. First event, and then this is time 0 split. Okay. So right now, let's just go into this guy. I don't even know what this thing's going to look like, so I'm going to just add some nodes. I'm going to put this one at 10, this one at 15, this one at 30, and that one can be at 0. So first, second, split it, second 75, and then this one can be, I don't know, like last or something. Split second 75, I'm just going to add 2 standard events too. One at 0, no, let's put this one at 5, and let's put this one at 200. Okay, so this is time 05er, and this is latter days. Yeah, okay. So I'm going to actually just go ahead and Control-Shift-T to bring this up. So right here we can kind of see, okay, so this thing, so we have our bottom event, our first event. This doesn't have any children coming off of it. This doesn't have any children coming off of it. So this is just being moved over according to this bottom event. You can see right here. It looks like it's being moved over according to that. This is clearly being moved over because it's not coming off of, like, right there like these other ones are. So it's coming off of last, I assume. And then time 05er, like that stuff's not doing anything. So this is just an initial sort of test. This is not taking second into account. It shouldn't. So you can see actually when I scrunch it up, it overlaps a little bit. Just because that's at 10, this is at 15. That's just a scale problem. If you want to fix that, you just scale it out. Scale the timeline out. That's what the scaling is for. Okay. So I just want to begin adding some nodes to some of these. So I'm just going to add a standard event to this one at 1,000. Did almost nothing for a long time. Okay, so that one's going to just be a specific like test of what that does. I'm going to add a split timeline to this at 50. More splitting. And let's go over here to more splitting and just add an event at 500. And stuff got split, yo. Okay, so if we... Oh, that's not good. Okay. So... that just exploded. So I'm going to figure out why. The searcher is null. This is... timeline parent.previous is null. Oh, right. Right, I see what happened. Yeah, okay, that just needs to be while searcher.null. Okay, so unfortunately all the time making that lovely timeline just got spent on this error. But that's what happens. Now we know we're looking not for previous. Because I already set it to previous right here. So I'd originally written that taking the previous into account, or not taking the previous into account, then I needed to, yeah. Oh well. Control D, Control S here. AKF. There. Just format everything with good old Control AKF. Okay. Let's see. Should I run another test right now? Just finish this off, see if I can run another test, and then call it there. Drink some water while this is loading up. Kind of wears you out a little bit talking as much as I do for these. Okay. Let's just add a split timeline. Couple standards. Let's go ahead and leave this at 0. First split. Let's put this at 50. Let's put this one at 300. Okay, first split, standard event, 500. No, not 5,003, 500. Doing stuff. Okay, so just right now, okay, first split, you can see that those unnamed events kind of shove it over a bit. So let's go ahead and name those events. Let's just call this one early library reading. And let's just call this one pi. So now you can see the early thing right here, that's being adjusted by that, right? Pi is not doing anything. If I change this name to something like tau, and I say pi, and instead of pi, let's just say a long line of text to test things with. Now you can see a long line of things to test things with is pushing that out, which is exactly what it should be doing. Now, what you'll find is if I go ahead and, Alt-A-E, and I put another one at 50 here, and I call this one longer line of text, sort of, and I check it, like, okay, so let's go ahead and make tau. Tau is not pi. Objectively true. See, this is now the problem that I need to solve, right? I need to say, oh, this is far enough out that this should be the candidate instead of this one. So I need to account for lines. So that's one of the problems I needed to solve, is you may recall. So, I need to fix that. There's doing stuff down there. So that's clearly one of the problems I need to fix. Let's go ahead and add another split timeline at like 250. Second split. Let's go into second split and let's add 2 split timelines, both at 50, because I feel like it. A split. B split. Yeah, because I'm creative. And then let's just add a standard event at 75, and let's call it not split, because that's not a split. Okay, add a standard event here, and a standard event there. Call this one Taco Tuesday invented, and let's put this one at 15, and let's go ahead and go to a split here, and say hot fudge sundaes for everyone. And let's put this at 500 for no reason. Okay, so if I come in here, okay, so first split is like really shoved out, because right here we have second split, which is being affected by a long line of text testings with, but not this, because otherwise it would be coming off of longer line of text, sort of, right? So it's being checked. Well, that doesn't work, but it's coming off of this. Not split is pushing off B split, which is pushing off Taco Tuesday, and Taco Tuesday is pushing off A split, so that's all good. Hot fudge sundaes for everyone is properly pushing this off. But remember, if I come over here to second split, and see, I've got both of those guys coming off at 50. So if I add a couple of standard events at 50, okay, so those are going to push out that. So those are going to kind of push that out, which you'll see that this is not getting adjusted by not split anymore. It's being adjusted by that guy, right? Because this is further out than that, which is correct. Now, the difficulty is getting stuff after that because of the way that this is working. But let's go ahead and move this up to 51, or down to 49, and then back up to 50. Okay. Now let's see what that does. Okay, so, yep, you can see that that's being accounted for properly with a split being coming off of there. Now, what I want to do is I want to move a split back as well. So let's go ahead and move a split back. 49 back up to 50. Okay, so now you can see the problem, right? This is looking at Taco Tuesday invented. So it's moving first split appropriately over for Taco Tuesday, but it is not taking into account the fact that I should be going after unnamed event right here instead of Taco Tuesday invented. So that's the other problem that I need to fix. I need to figure out how to fix that particular issue. And this is expected behavior. Like I said, like I was predicting that would happen. Hot fudge sundaes for everyone is way down there. So obviously this can get quite spread. Now, it would be kind of nice, because my zoom right now is doing this behavior, which allows me to, like, zoom at a specific spot, right? But it's a vertical zoom. It doesn't do anything horizontally, which is fine. But it would be kind of nice to have an alternative zoom that actually scaled everything. Excuse me, had some delicious water. So I'm not sure if that's something that I can do. I might look into that a little bit in between stuff as well, just to see if it's possible to do kind of a big picture zoom, where this could, where I could have like a Control Shift or Control Alt scroll wheel to zoom, kind of like how you'd look at a picture when you zoom in and out, and so I could get kind of a different sort of view. I'm not sure if that's something that's feasible or not, but I might look into if it is. Anyway, so what I need to do now is figure out how to fix the line problem. It's unfortunately somewhat tricky because I think I almost need to like do a second pass. See what I'm saying? So I'm just going to talk a little bit out loud while I'm thinking through this. I know this is going to be a very long episode, but so you'll see right here like how far this needs to be out. I can't account for over here. Like if this were like a line coming off of down here, right? Where there's a line coming really long down here, that might need to affect that, or yeah, I don't know. I'll think about the line problem. I think that's going to go ahead and wrap for today, and hopefully I can figure this thing out pretty quickly. We'll see. And maybe I can figure out having a different type of zoom as well. Anyway, until next time, everyone, take care. Bye-bye.